Hello grade 11, I'm teacher Riza, or you can call me Mom Rice, your teacher in general mathematics. Our topic for this week are the following. First, representing real-life situations using rational functions. Second, rational functions, equations, and inequalities. Third, solving rational equations and inequalities. Fourth, representation of rational function. Fifth, finding the domain and range of rational function. To start, let's analyze and solve the problem. The local barangay of Torayong received a budget of 100,000 pesos to provide medical checkups for the children in the barangay. The amount is to be allotted equally among all the children in the barangay. Write an equation representing the relationship of the allotted amount per child, which is y variable, versus the total number of children, which represent x variable. Fill up the table with the different allotment amounts of the different values for the number of children. We have the number of children, x, and the allotted amount, y. For x, we have 10, 20, 50, 100, 200, 300, 500, and 1000. So how much will be the allotted amount for each child if there are 10 children in the barangay? Yes, it's 10,000 pesos. What about if there are 10 children in the barangay? Correct, we have 5,000 pesos. What about for 50 children in the barangay? It's 2,000 pesos each child. What about for 100 children in the barangay? We have 1,000 pesos. For 200, we have 500 pesos. For 300 children in the barangay, 333 pesos and 33 centavos. For 500 children in the barangay, the allotted amount for each child will be 200 pesos. For 1,000 children in the barangay, the allotted amount is 100 pesos. How did you get 10,000? If there are 10 children in the barangay? Correct, you divide 100,000 pesos by 10. Or, to get the allotted amount,
y is equal to 100,000 over x, the number of children, or since y is the function of x, f of x is equal to 100,000 over x.
What about if a philanthropist wants to supplement the budget allotted for each child by providing an additional of 750 pesos for each child? Construct a function representing this relationship. So we have here the number of children for x and the allotted amount for y. Since the philanthropist will give additional 750 pesos for each child, so for the number of children, which is 10, the allotted amount now will be 10,750 pesos. For 20 children, yes, it's 5,750 pesos. For 50 children, the allotted amount will be 2,750 pesos. For 100 children, it's 1,750 pesos. For 200 children, the allotted amount will be 1,250 pesos. For 300 children, yes, the amount will be given is 1,083 pesos and 33 centavos. For 500 children, the amount will be 950 pesos. And for 1,000 children, the allotted amount for each child will be 850 pesos.
How did you get it? Excellent! You add 750 from y is equal to 100,000 over x, or f of x is equal to 100,000 over x plus 750.
My dear grade 11 students, 100,000 over x is a rational expression. Rational expression that can be written as a ratio of two polynomials Some example of these are 5 over x, x squared plus 2x plus 3 over x plus 1, and 2 over x minus 3. 100,000 over x equal to 200 is a rational equation. Rational equation is an equation involving rational expression.
Example of this, 2 over x minus 3 over 2x is equal to 1 over 5.
Y is equal to 100,000 over x, or f of x equal to 100,000 over x is a rational function. Rational function is a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomial functions, and q of x is not a zero function. Example, f of x is equal to x squared plus 2x plus 3 over x plus 1. Rational inequality is an equality involving rational expression. Example, 5 over x minus 3 is less than or equal to 2 over x. Now, determine whether the given is a rational function, rational equation, rational inequality, or none of these. Clap your hand if your answer is rational function. Give me 5 if your answer is a rational equation. Thumbs up if your answer is a rational inequality. Thumbs down if your answer is none of these. Are you ready? Number 1. Y is equal to 2x squared minus 7x plus 3. Correct, it's a rational function. Number 2. 2 plus x over x minus 1 is equal to 8. Very good, it's a rational equation. Number 3. 2x is greater than 7 over x plus 4. Yes, it's a rational inequality. Number 4. G of x is equal to 6 minus x plus 3 over x squared minus 5. Correct, it's a rational function. Number 5. 2x over 3 less than or equal to 5 over x plus 2. Excellent, it's a rational inequality. Number 6. The square root of x plus 2 is equal to 8. Yes, it's none of this. Number 7. X over 5 is equal to 3 over 2x minus 1. Correct, it's a rational equation. Number 8. F of x is equal to x plus 1 over x squared minus 9. That's it, it's a rational function. Number 9. 2x minus 3 over x minus 3 minus 2 is greater than 0. True, it's a rational inequality. Number 10. F of x is equal to 2x plus 1 over x minus 1. Very good, it's a rational function. Now, solving rational equations and inequalities. And to solve rational equation, eliminate denominators by multiplying each term of the equation by the least common denominator. Second, note that eliminating denominators may introduce extraneous solution. Check the solution of the transform equations with the original equation. Number 1. Solve for x. 2 over x minus 3 over 2x is equal to 1 over 5. The least common denominator of x, 2x, and 5 is 10x. To eliminate denominators, multiply each term of the equation by the least common denominator, 10x. So we have 10x times 2 over x minus 10x times 3 over 2x is equal to 10x times 1 over 5. Cancel x, so we have 10 times 2 is equal to 20, and negative 10 times 3 divided by 2 is equal to negative 15, and 10x divided by 5 is equal to 2x. 20 minus 15 is equal to 5, which is equal to 2x. Multiplying both sides by 1/2, so we have 1/2 times 5 is equal to 1/2 times 2x. So we have 5 over 2 is equal to x, or x is equal to 5/2. To check the solution, then substituting x is equal to 5 over 2 in the original equation, must make this equation true. From the original equation, 2 over x minus 3 over 2x is equal to 1 over 5. Substitute the value of x, which is 5 half, so we have now 2 over 5 over 2 minus 3 over 2 times 5 half is equal to 1 over 5. So 4/5 minus 3/5 is equal to 1/5. So 1/5 now is equal to 1/5, which is true, so therefore the solution is correct. Solve the problem. In an inter-barangay basketball league, the team from Barangay Cabarwan has won 12 out of 25 games, a winning percentage of 48%. How many games they should win in a row to improve their win percentage to 60%? Solution: let x represent the number of games that they need to win to raise their percentage to 60% or 0.6. The team has already won 12 out of their 25 games. If they win x games in a row to increase their percentage to 60%, then they will have played 12 plus x games out of their 25 plus x games. The equation is 12 plus x over 25 plus x is equal to 0.6. Multiply 25 plus x to both sides of the equation, so we have 25 plus x times 12 plus x over 25 plus x is equal to 0.6 times 25 plus x. So 12 plus x is equal to 0.6 times 25 plus 0.6 times x. So 12 plus x is equal to 15 plus 0.6x. X minus 0.6x is equal to 15 minus 12. So 0.4x is equal to 3. Multiplying both sides by 1 over 0.4. So we have 1 over 0.4 times 0.4x is equal to 3 times 1 over 0.4, which is x is equal to 3 over 0.4. 3 divided by 0.4 is equal to 7.5, rounded to 8. Therefore, Barangay Cabarwan needs to win 8 games in a row to raise their winning percentage of 60%. To solve rational inequality, first, rewrite the inequality as a single rational expression on the other side of the inequality symbol and 0 on the other side. Determine over what intervals the rational expression takes on positive and negative values. Under this, locate the x values for which the rational expression is 0 or undefined. Factoring the numerator and denominator is useful strategy. Mark the numbers found on number line. Use shaded circle to indicate that the values is included for the solution set, and the hollow circle to indicate that the value is excluded. This number partition the number line into interval. Select a test point within the interior of each interval. The sign of the rational expression at this test point is also the sign of the rational expression at each interior point in the aforementioned interval. Summarize the intervals containing the solution. Solve the inequality 2x over x plus 1 is greater than or equal to 1. First, rewrite the inequality as a single rational expression on one side and 0 on the other side. Subtract both sides by 1. So we have 2x over x plus 1 minus 1 is greater than or equal to 1 minus 1. Or 2x over x plus 1 minus x plus 1 over x plus 1 is greater than or equal to 0. 2x minus x plus 1 over x plus 1 is greater than or equal to 0. So x minus 1 over x plus 1 is greater than or equal to 0. The values x is equal to 1 is included in the solution since it makes the fraction equal to 0. That is 1 minus 1 over 1 plus 1 is equal to 0 over 1 is equal to 0. While x is equal to negative 1 makes the fraction undefined. That is negative 1 minus 1 over negative 1 plus 1 is equal to negative 2 over 0 is undefined. Use shaded circle for x is equal to 1 because it's a solution, and hollow circle x is equal to negative 1 because it's not a solution. Choose convenient test point in the intervals determined by negative 1 and 1 to determine the sign of x minus 1 over x plus 1 in these intervals. Construct a table of signs. So we have here from the table interval, test point, x minus 1, x plus 1, and x minus 1 over x plus 1. For an interval x is less than negative 1 with test point of x is equal to negative 2. For x minus 1, we have negative 2 minus 1 is equal to negative 3. We don't need to write negative 3 anymore, just write the sign which is negative. For x plus 1, negative 2 plus 1 is equal to negative 1. So we have negative. For x minus 1, which is negative, and x plus 1, which is also negative, so negative divided by negative is equal to positive. For an interval x is less than 1 but greater than negative 1, the test point is x is equal to 0. So 0 minus 1 is equal to negative, and 0 plus 1 is equal to positive, and negative divided by positive is equal to negative. For an interval x is greater than 1, with the test point of x is equal to 2. 2 minus 1 is positive, and 2 plus 1 is positive. Positive divided by positive is equal to positive. Since we're looking for the intervals where the rational expression is positive or 0, we determine the solution to be the set of ordered pair such that x is an element of real number wherein x is less than negative 1 or x is greater than or equal 1. Applying rational inequality in problem solving, a box with a square base is to have a volume of 8 cubic meters. Let x be the length of the side of the square base and h be the height of the box. What are the possible measurements of a side of a square base if the height should be longer than a side of the square base? Of the box is the product of its length, width, and height. Since square base, then volume is equal to x squared times h, and v is equal to 8 cubic meter. 8 is equal to x squared times h, and so h is equal to 8 over x squared. Since that height should be longer than the side of the square base, so 8 over x squared is greater than x. To make the right side equal to 0, subtract both sides by x. 8 over x squared minus x is greater than x minus x. And 8 over x squared minus x is greater than 0. 8 minus x cubed over x squared is greater than 0. By factoring 8 minus x cubed, we have 2 minus x times quantity 4 plus 2x plus x squared over x squared is greater than 0. The zeros of 2 minus x times x plus 2x plus squared are x equal to 2 and x is equal to 0. Using number line 0 and 2. Construct a table of signs with an interval, test point, 2 minus x, x squared plus 2x plus 4, x squared, and 2 minus x and 4 plus 2x plus x squared over x squared. With the interval of x is less than 0, with the test point of x is equal to negative 1. For 2 minus x, positive. For x squared plus 2x plus 4, positive. For x squared, positive. Then, multiplying positive times positive divided by positive is equal to positive. For an interval x is less than 2 but greater than 0, with the test point of x is equal to 1. For 2 minus x, positive. For x squared plus 2x plus 4 is positive. For x squared is positive. And positive times positive is positive divided by positive is also equal to positive. For x greater than 2, where the test point is x equal to 3. For 2 minus x, we have negative. For x squared plus 12 plus 4 is positive. For x squared, positive. Negative times positive is negative, divided by positive is negative. Since we're looking for values greater than 0, it must be positive. Valid values would be x is less than 2 but greater than 0. Therefore, the height of the box should be less than 2 meters. Representation of rational function through its table of values, graph, and equation. Example number 1 through equation. Represent the speed of a runner as a function of the time it takes to run 100 meters in the track. Solution. Since the speed of a runner depends on the time it takes to run 100 meters, we can represent speed as a function of time. So, let x the time it takes the runner to run 100 meters. So the speed can be represented as s of x is equal to 100 over x. Example number 2, by the table of values. Continuing the scenario, construct a table of values for the speed of runner against different run times. Solution. Table of values can help us determine the behavior of a function as the variable x changes. In s of x is equal to 100 over x. For x, we have the values of 10, 12, 14, 16, 18, and 20. If x is equal to 10, so we have s of 10 is equal to 100 divided by 10 is equal to 10. If x is equal to 12, so s of 12 is equal to 100 divided by 12 is equal to 8.33. If x is equal to 14, s of x is equal to 7.14. If x is equal to 16, s of x is equal to 6.25. If x is equal to 18, s of x is equal to 5.56. If x is equal to 20, s of x is equal to 5. What did you observe from the table of values? Yes, from the table, you can observe the speed decreases with time. Now, we can use the graph to determine if the points on the function follow a smooth curve or a straight line. Example number 3, by graphing. Plot the points on the table of values on the Cartesian plane. Determine if the points on the function s of x is equal to 100 over x follow a smooth curve or straight line. Solution. Assign points on the Cartesian plane for each entity on the table of values. For first ordered pair, we have 10, 10 is point A. Then point B is 12 and 8.33. Point C is 14 and 7.14. Point D is 16 and 6.25. Point E is 18 and 5.56. And point F is 20 and 5. By connecting the points, we can see that they are not collinear, but rather follows a smooth curve. Represent the rational function given by f of x is equal to x minus 1 over x plus 1. If x is equal to negative 10, so function of negative 10 is equal to negative 10 minus 1 over negative 10 plus 1 is equal to 1.22. If x is negative 8, f of x is equal to 1.29. If x is equal to negative 6, f of x is equal to 1.4. If x is equal to negative 4, f of x is equal to 1.67. If x is equal to negative 2, f of x is equal to 3. If x is equal to 0, f of x is equal to negative 1. If x is equal to 2, f of x is equal to 0.33. If x is equal to 4, f of x is equal to 0.6. If x is equal to 6, f of x is equal to 0.71. If x is equal to 8, f of x is equal to 0.78. And if x is 10, f of x is 0.82. Plotting of points, so we have point A, point B, point C, point D, point E, point F, point G, point H, point I, point J, and point K. Connecting the points. Is the graph correct? Are we going to connect point E to point F? Note that in f of x is equal to x minus 1 over x plus 1, if x is a negative 1, that is function of negative 1 is negative 1 minus 1 over negative 1 plus 1 is equal to negative 2 over 0 is undefined. F of x is undefined at x is negative 1, so there must be no line at x is equal to negative 1. So therefore, the graph should be like this. We're not going to connect point E to point F because there is no point in negative 1. Let's go back to the problem a while ago. In an inter-barangay basketball league, the team from Barangay Cabarwan has won 12 out of 25 games, a winning percentage of 48%. How many games should they win in a row to improve their win percentage to 60%? What will be the winning percentage if they win? Letter A, 10 games in a row. Letter B, 15 games, 20 games, 30 games, and 50 games. C, can they reach a 100% winning percentage? Solution. Let X be the number of wins the team needs to win in a row, and P, the percentage, is the function of the number of wins that the teams need to win. So, P of X is equal to 12 plus X over 25 plus X. So we have here the table. For X, we have 10, 15, 20, 30, 50, and 100. If X is equal to 10, P of 10 is equal to 12 plus 10 over 25 plus 10 is equal to 0.63 or 63%. If X is equal to 15, P of 15 is equal to 12 plus 15 over 25 plus 15 is equal to 0.68 or 68%. If X is equal to 20, F of X is equal to 0.71 or 71%. If X is equal to 30, F of X is equal to 0.76 or 76%. If X is equal to 50, F of X is equal to 0.83 or 83%. If X is equal to 100, F of X is equal to 0.90 or 90%. The question for letter C is, can they reach a 100% winning percentage? No. Even if we increase the number of winnings to 200 or 300, it will never reach a 100% winning. Why? Because the denominator 25 plus x is greater than the numerator. So 100% cannot be achieved. This is reasonable since the team has lost 13 games already, so they cannot be perfect. So this is Teacher Riza or Mom Rice saying, have no fear of perfection. You'll never reach it. That's all for week 2 grade 11. Till next week again. Have a blessed day.